On November 20th, 1969, something happened on the moon that even NASA engineers struggled to explain. After the Apollo 12 astronauts lifted off and headed home, Mission Control issued one final command: crash the empty ascent stage of the lunar module back onto the moon. A violent impact, a plume of dust, a shock wave racing through the ground. 60 kilometers away, the seismic station left by the astronauts began to shake. Its needles jumped instantly, just as expected. But then, the signal refused to fade. Instead of tapering off like any normal quake on Earth, the vibrations kept going. And going. And going. 5 minutes passed. 10 minutes. 20. Inside Mission Control, the room fell silent. No one spoke. Everyone just stared at the data pouring in, because the moon simply would not stop ringing. It echoed with a strange, metallic resonance, a slow, steady pulse that lasted for nearly an hour. One engineer finally wrote a single, eerie sentence in his report: "The moon rang like a bell." That phrase spread quietly through NASA, then leaked to the public, and from there it became one of the most mysterious lines in all of space exploration. Why did the moon behave like that? What was hiding beneath its cold, silent surface? And why did this one experiment spark decades of theories about a hollow interior, alien engineering, and a truth NASA supposedly kept quiet? Tonight we dig into the real story. What happened? What scientists discovered? And why this strange ringing still haunts the history of Apollo. When the Apollo missions explored the moon, they didn't just plant flags and collect rocks. They left behind something far more important: a way to listen to the moon. Starting with Apollo 11 and continuing through Apollo 12, 14, 15, and 16, astronauts installed a network of small seismic stations across the lunar surface. These devices were simple by today's standards, but incredibly sensitive. For nearly 8 years, from 1969 to 1977, they recorded every tremor, impact, and vibration that passed through the moon. By the end, NASA had collected more than 12,000 seismic events. And those events fell into 4 strange categories. First, deep moonquakes, occurring hundreds of kilometers below the surface. These weren't caused by tectonic plates. They were triggered by Earth gravity, pulling and stretching the moon like a slow-motion tide. Second, shallow moonquakes, much rarer, but shockingly powerful. Some of them reached the equivalent of magnitude 5 on Earth, strong enough to damage buildings if they happened here. Third, meteor impacts. With no atmosphere to burn them up, even small rocks slammed directly into the moon, sending seismic waves rippling outward. And finally, the artificial signals, the ones created when NASA intentionally crashed hardware into the surface, just like Apollo 12. These instruments revealed something surprising. The moon isn't a silent, dead world. It moves. It creaks. It contracts as it cools. It even shakes with unexpected bursts of energy. But among all the data, all the quakes, all the impacts, nothing was as strange or as unforgettable as the signal recorded on that November night in 1969. The moment when the moon refused to stop ringing. When the ascent stage of Apollo 12 slammed into the moon, the seismic station captured the impact instantly. A sharp spike, exactly what the engineers expected. But right after that first jolt, something completely unexpected began to unfold. Instead of fading away, the signal lingered. Its waves rose and fell in a slow, rhythmic pattern, like echoes bouncing inside a giant, hollow shell. 5 minutes passed, then 10, then 20. The vibration simply refused to die. Inside Mission Control, engineers leaned closer to their monitors, searching for a malfunction, a glitch, anything that could explain what they were seeing. But the instruments were working perfectly. The moon was ringing. It wasn't a sound you could hear with your ears. It was a seismic resonance, a low, metallic trembling that rolled through the crust, again and again, as if the energy had nowhere to go. On Earth, quakes fade quickly. Water, soil, and molten rock absorb the shock. But the moon is bone-dry, brittle, and fractured, a world of ancient stone with almost no material to muffle the waves. So the energy just kept bouncing. 30 minutes, 40 minutes. The engineers exchanged uneasy glances. This wasn't in any textbook. No one had predicted it. No model had suggested the moon could behave like this. By the time the signal finally weakened, nearly an hour after the impact, Mission Control was left with a single, haunting question. Why does the moon resonate like that? That one moment, the moon trembling long after the crash, became the seed of a mystery that would grow far beyond NASA's walls. A mystery that would challenge scientists, fuel conspiracy theories, and raise the possibility that the moon's interior was far stranger than anyone had imagined. After NASA released the data, the strange ringing didn't just stay inside scientific circles. It leaked out, and the public began to fill in the blanks. One idea in particular took on a life of its own. In 1970, two Soviet researchers, Mikhail Vasin and Alexander Sherbakov, published a bold, provocative theory. They asked a question that startled even fellow scientists. What if the moon is not a natural object? Their article suggested that the moon might be a megastructure, a hollow vessel, a colossal spacecraft placed in orbit around Earth long ago. And suddenly, the Apollo 12 ringing became their strongest piece of evidence. They argued that the moon's unusually low density, its perfectly stable orbit, and its oversized appearance in our sky were all hints that something intelligent might have engineered it. To them, the ringing wasn't just a seismic quirk. It was the sound of a giant shell, a hollow sphere wrapped in rock. From there, the theory exploded. Some claimed the moon was an ancient observatory watching humanity from above. Others said it housed enormous caverns, lit by strange artificial glows captured in old telescope photographs. A few went further, suggesting alien machinery, metallic structures under the crust, or long-forgotten civilizations hiding in the far side's shadow. Science fiction loved it. Books ran with it. TV shows adapted it. And decades later, the movie Moonfall would turn the entire idea into a full-blown Hollywood storyline. But the truth is, all of this began with a single moment, a single vibration. That eerie, unending ring recorded by a lonely seismometer in 1969. A sound that felt too strange, too unnatural, for some people to ever let it go. For decades, scientists have worked to separate the myth from the measurable. And their conclusion is clear: the moon is not hollow. It has a crust, a mantle, and a small metallic core, just like Earth, but colder, drier, and far more brittle. So why did it ring? Because the moon's interior is unlike anything on our planet. It contains almost no water, very few soft minerals, and no molten oceans of magma to absorb energy. When a shock wave enters this kind of world, it doesn't fade quickly. It ricochets, bouncing between fractures and layers of ancient rock, losing strength only slowly, like a tuning fork struck in deep space. That explains part of the mystery, but not all of it. Some shallow moonquakes recorded by Apollo were so intense that if they happened on Earth, they would seriously damage buildings. And some lasted for more than 10 minutes, far longer than seismic models predicted. Even stranger, a few quakes occurred at times that made no sense, not tied to meteor impacts, not linked to tidal forces, and not explained by the moon cooling and shrinking. NASA eventually admitted something quietly. We still do not fully understand the mechanisms behind these events. Modern analysis has only deepened the puzzle. The moon seems to be contracting, forming fresh faults that shouldn't exist on such an old, inactive world. And certain seismic waves recorded on the far side behave in ways researchers are still trying to interpret. So yes, science rejects the hollow moon. But the scientific explanation that replaces it isn't comforting. It's unsettling because it suggests the moon is not dead, not dormant, not silent. It is a world that moves, shifts, and resonates in ways we still don't fully understand. Even today, with decades of new research, there are parts of the moon's behavior that scientists still struggle to explain. Take the Apollo 12 impact, for example. Modern computer models, far more advanced than anything available in 1969, still have trouble recreating a resonance that lasts nearly an hour. According to the simulations, the energy should have faded sooner, much sooner. But the real moon did something else. And then there are the shallow moonquakes, those powerful, unpredictable jolts. Some of them struck at times that matched no known trigger. No meteor, no tidal stress, no thermal expansion from lunar sunrise or sunset. They just happened, as if the moon had its own internal clock, ticking in ways we don't understand. There's also the question of the moon's interior. For years, researchers believed the core was small and solid. But newer data hints at something more complicated, a partially molten layer, a transition zone that behaves strangely under stress, and patterns of wave reflection that don't line up with the simple models taught in textbooks. And on the far side, some seismic signals contain odd distortions, subtle bends in the data that suggest hidden structures, unexpected density changes, or geological processes that no one has mapped yet. None of this proves the moon is hollow, but it does show something else. The moon is not fully understood, not even close. It's a world that responds to shocks in ways that defy easy explanation. A world that rings, shifts, and quakes, with a rhythm that doesn't always match our expectations. And every time scientists think they've solved the puzzle, the data opens a new question, a deeper layer, a darker corner of a world we thought we knew. In the end, the truth behind the moon's ringing is not a single twist or a hidden machine or a grand alien design. It's something stranger. The moon is not hollow. It's not a spacecraft. And it's not an ancient eye in the sky watching us. But it did resonate. It did tremble for nearly an hour. And it does respond to shocks in ways that our best models still struggle to predict. That's what makes this mystery so unsettling. It lives in the space between what we can measure and what we can't yet explain. A reminder that even the world hanging over our heads still keeps secrets buried deep within its crust. Thank you for exploring this mystery with us. If you're drawn to places where science and legend overlap, where the answers are real, but the questions don't quite go away, you're in the right place. Because next, we're leaving the silent rock of the moon and turning our ears back toward Earth. Across the United States, from quiet coastal towns to empty desert highways, people have reported something terrifying. Deafening booms in the sky with no storm, no jets, and no clear source. Sometimes they shake houses. Sometimes they rattle windows. Sometimes they roll across the landscape like distant artillery from a war no one can see. In our next episode, Earth's Hidden Mysteries, America's Mystery Sky Booms, Sounds with No Source, USA. Mysterious explosions, invisible origins, and a sky that sounds like it's trying to speak.